Hello, my name is Ajay Viswas. I'm a final year undergraduate student at the Department of Mechanical Engineering, enrolled in this dual degree course, IIT Kharagpur. Today I have built a complete order execution backend for Eterna Labs that simulates a real trading engine with real-time updates and robust queue-based processing. So the API is built using Fastify because of its high performance and clean routing. One interesting part is that the same endpoint supports both HTTP post for submitting new orders and WebSocket connections for streaming live. This means that the client immediately sees status like pending, routing, and building submitted and confirmed at the same time. For processing, I am using BullMQ with Redis. Every order gets pushed to a queue called order execution, and after that, a worker picks it up with concurrency control and exponential backup. This helps me handle retires gracefully and ensures that the system can take and scale horizontally if needed. When a job is being processed, the engine integrates with mock DEX router, which stimulates Radium and Meteora routing logic, which I can show you here. So, when a job is being processed, the engine integrates with mockdex router. So it fetches mock codes, builds a swap transaction, handles slippage limits, and decides which DEX to execute on. All execution steps get persisted along with detailed payloads. I am using PostgreSQL to store both orders and their full-time life cycle of events. This makes it very easy to query exact routing decisions, executed price, TX hash map, timestamps, and past failures. For real-time updates, the worker broadcasts each event through an event emitter to all active WebSockets subscribers, so client always see the latest state. Here is the database schema for the order, and here is how it is get pushed or broadcasted. The backend is fully typed with TypeScript, logs cleanly using Pino, and has automated migration, structured models, and unit tests for both HTTP routes and WebSocket lifecycle. Here you can see that. Yeah. So the overall system is fast, fault tolerant, and structured exactly like a real world trading engine. It first goes to API, then queue, then workers, and after that to DEX router, which gives persistent and real time streaming. So I can give you a small demo of how my backend runs. So currently my backend runs at 4,000 ports. After that, I'll show you how it runs. So with the help of, I'm using Postman for testing my endpoints, and also has written the test scripts for that for automate the tests. So starting off with our first endpoint, which is /API/health. Let's check it. So as you can see, we have received the response of /API/health, and you can also view all these endpoints that I have mentioned in my readme.md file. Here, here's the first endpoint for checking the health, like for checking is my backend running, and it is running absolutely fine. Now let's put some order. Starting off with API/orders/execute, and changing the changing the method to post, and after that we can send the request data as let's change it to 100 and let's change it to 400. Okay, let's click. Okay, as you can see, my my order is get created, and it is uh, first sent to the queue, and where it is first pending, and after that it is routing, and after that, after the confirmation, it is building that order in that queue, and after that it is get submitted, and after that it is confirmed. Okay. Here we have created the order. Let's find out how many. Let's first check is the order is in my database or not. For that, we will again change the method to get, and let's check it. Here you can see in the postman, we have successfully created our order in the database. Let's check if the same order. Let's check the how many orders are being created till this date. For that we will use API slash order slash the order ID slash events. Like if that same order ID has created another order in the past or not. For that we will just type events in front at the end of this, and simply check. Yes, we have created orders, and it is also showing in my backend terminal that we have two orders with the same order ID, which is being created for Radium and for Meteora. And after that, um, and after that, these same endpoints will also work for WebSockets for live streaming or for live streaming. Here you can see we just have to type WS in front of this to run it in to run it for the WebSockets. You can check it using curl. You can check all these endpoints using curl. Okay, so here is the complete demonstration of my backend system, and I have mentioned all and each and every step of how my backend runs, and I have also included a complete flowchart of how the processes is being made, and how the API are calling one another, and how the order is being transmitted to queue, and after that in queue how it is proceed to the front end of that part. As you can see, I have mentioned the overflow here in the readme.md file. So that's it from my side. Thank you and have a nice day.